So it is my pleasure to introduce this month's speaker, Dr. Kelly Hamby, who is an associate professor and extension specialist with the Entomology Department of University of Maryland, College Park, which is my old alumni. I've had the pleasure to know Kelly for many years now, and she is an amazing scientist and has done lots of work on spotted wing Drosophila. So we were very fortunate that she accepted our invitation to speak to us today. So without further ado, Kelly. The floor is yours.
All right, thank you, Emily, and thanks for the invitation. As mentioned, I'm going to be talking about spotted-winged Drosophila, and so I think it's good to start with why are we talking about spotted-winged Drosophila? So spotted-winged Drosophila has become, since its invasion into the continental United States from Southeast Asia, the key insect pest of soft-skinned fruits in the United States, and actually in many regions where after it began its global range expansion. So the types of damage that it does depends on the fruit. But again, it really likes these soft skinned fruits, and I'm going to talk a bit about why that is in a second. And so here you can see this is a larva inside a raspberry. And this is this life stage that is causing most of the damage. But there's also in the cherry, you can see this pitting, and also a bit in the blueberry, you can see this pitting. This is from where the female laid her egg inside the fruit, and then that egg is what hatched into the larva. So sometimes you're going to see sunken areas in some of these firmer fruits, like cherries and blueberries, whereas you're going to see more soft, leaky fruits in some of these other fruits, like caneberries. And in strawberries, it almost looks like a bruise where the spotted-winged Drosophila damage is occurring. So they can get into all of these fruit crops, and that's why we're talking about them today. So to effectively manage an insect pest, you really have to understand its biology and life cycle. So as I alluded to, the adult spotted-winged Drosophila is attracted to fresh, ripe fruit. And this is what makes it different from the Drosophila that you encounter in your fruit bowl or Drosophila melanogaster, our genetic model organism. It's very similar in size. It's very similar genetically, but it has an egg-laying structure or an ovipositor that enables it to cut into the fruit and lay its egg directly in here. So here you can see, here it is laying this is a female fly laying her egg directly into fresh ripening fruit. This is what the egg looks like. It has these two breathing tubes that they usually have. They need to position it just right so that the breathing tubes are outside of the fruit so they can breathe. And then in 10 to 15 days, it can go all the way from an egg to an adult, depending on the temperature. The warmer it is, the faster it goes. Now that egg is going to hatch into a small larva, which then goes through 3 larval instars, and before it pupates, and it may pupate inside the fruit. And again, the part of the pupa that needs to breathe is up and outside of the fruit when it pupates in the fruit, or they may drop out and pupate in the soil, depending on the type of fruit that it is. And again, then the adult flies go off, they find a mate, and the cycle starts again. So they can reproduce very quickly. What else do we know about them in terms of their seasonal and daily activities? We know that in this time of year, in the crop growing season, they're typically active around dawn and dusk, where it's a little bit cooler and a little bit more humid. So that's their peak flight activity is going to be dawn and dusk. But the vast majority of the population is actually in those juvenile stages, the eggs, larvae, and pupae, rather than the adults in terms of the total population that's out there. And the population is moving between the woods and into the fields, back and forth, maybe even on a scale of within a day. So they may be in the beginning of the day in the wild vegetation and then moving into the fields and then coming back. In the winter, they're typically more active in the middle of the day when it's warmer. And they're spending all of their time as they're overwintering as adults, and they're spending all of their time in the wild vegetation. So this understanding and this work that we've done to try to understand how this fly utilizes its resources is what underlies our recommendations for management. So in terms of spotted-winged Drosophila integrated pest management, we have all of the different strategies, starting, of course, with the tactics that you can use to prevent and avoid them, moving through monitoring and risk assessment. Then, if you discover that you do have an issue, the management interventions, chemical, cultural, and biological. And then there's some post-harvest mitigation. So today I'm going to walk through each of these different sections of our spotted-winged Drosophila IPM program. So starting with prevention and avoidance. I just discussed they overwinter as adult flies. Um, and this early season population builds from those adults that successfully overwinter. So they're always at their smallest population in the early spring as they're coming out of overwintering. This means that the pressure or the amount of flies out there that could be laying eggs in your crop is increasing over the season. So the earliest crops get the least damage, and the latest crops get the most damage, and it's hardest to manage in. So as much as possible, choosing earlier crops can help reduce your spotted wing Drosophila issues. Now, this doesn't work out every year because some years we have seen significant damage in some of those early crops as well. It's just a little bit less consistent than those later crops. So, for example, in 2020, we saw significant damage in cherries. Why did we see significant damage in cherries? We think part of this variation, again, is likely due to the differences in winters, how cold those winters are. So you can see in 2020, the minimum temperature only got to 15 Fahrenheit, so it never really got that cold. And the number of days over 32 degrees Fahrenheit was around 63. But also, it's not just the temperature, it's also the snow cover because that snow provides insulation. So from winter to winter, they may be surviving better or not as well. The other thing that happened in that year is that cherry damage was actually occurring in late June and early July. So it was a bit of a later cherry harvest that year. And spotted wing Drosophila tends to be active by late June and early July in our area. In fact, if you look at our 2025 early season infestation comparisons, so we were sampling, we started in July, at July 11th, we were sampling strawberries and cherries as they were available. Also, as they began to ripen, which was a little bit later that year in mid-June, spot blueberries and caneberries. And then in this whole time, we were sampling also non-crop fruits like honeysuckles, mulberries, and wild black raspberries that were kind of in the forest. You can see spotted wing Drosophila was already infesting. So this is the number of spotted wing Drosophila per gram of fruit that we found. They were already infesting the wild fruits by June 11th. And we see a small amount of damage from spotted wing Drosophila in strawberries and cherries. We also saw a little bit of damage in blueberries, but where we're really seeing a wider range of damage and higher damage is in caneberries. And this is in part because they really, really are attracted to caneberries. They like caneberries, blackberries, raspberries, and red raspberries and black raspberries. So if you are growing caneberries, you are going to be experiencing the heaviest spotted wing Drosophila pressure. And it's both a combination of when the timing of their fruiting and their attractiveness as hosts to spotted wing Drosophila. Despite that, still earlier cultivars are going to experience lower pressure. It only gets worse as the population builds and the season progresses. So summer-bearing caneberries tend to have less pressure than fall-bearing caneberries and be a little bit easier to be on top of than the fall-bearing caneberries. Some other things that you can do to try to reduce your spotted wing Drosophila from the beginning is thinking about having the firmer fruit. So we know that firmer fruit is less favored. There's also been some research into using biofilms and foliar calcium fertilizers to try to make the thickness of the skin firmer to reduce their attractiveness to spotted wing Drosophila. Now, all of these management strategies will fall apart if there's nothing else for spotted wing Drosophila to eat, but this does help. This does help in combination with all these other IPM tactics we're going to talk about. Another thing that has been explored really well is using exclusion netting. So making complete exclusion netted tunnels. And this has been explored in blueberries and in caneberries. You need the mesh netting to be less than 1 millimeter to exclude the flies. And it will work if it's done correctly. Some tips that have been really important for doing this is first you have to install it before spotted wing Drosophila is in the fruit. Otherwise, you just build a spotted wing Drosophila infestation under your tunnel. And then you also have to continue to keep the flies out of the tunnels. So one thing that can help with this is having one of these doors like you might have if you go to the zoo and see the aviary, or you go to a butterfly house where you have a double door to help reduce the organisms coming in. They also have found if you try to trap the spotted wing Drosophila out from underneath your tunnel, it doesn't seem to help reduce infestation underneath the tunnel. So it's really important to get that netting installed before the spotted Drosophila. In some crops like caneberries, pollination may be a bit of an issue because it continues to fruit and flower after you've put the net up, versus blueberries, you get more of a one-time pollination and you can put it up after pollination. So you may need bumblebees under those tunnels. One of the advantages of doing this strategy is that tunnel-grown fruit is often higher quality. It is possible to get 100% control of spotted wing Drosophila without needing additional insecticide sprays, especially in blueberries. You may need a few to clean up some messes, especially if a storm or something puts a hole in your net and you have to repair it. And it not only does it control spotted wing Drosophila, but it also reduces damage due to weather events and also birds. So this has kind of a one-stop thing that will help you control multiple issues in your crops. So after prevention and avoidance, we have monitoring and risk assessment. There are a couple of ways that you can monitor for spotted wing Drosophila. As I mentioned, these are pretty small fruit flies. So here is an adult male and female on the raspberry. The males have spots, which is where that name spotted wing Drosophila comes from, but the females do not have spots. So keep that in mind if you're trying to monitor yourself in terms of identification. For adult monitoring, there are food lure-based baits, or you can purchase a synthetic lure to attract them, and then you need to have some kind of drowning solution or sticky card to capture them. There are a lot of different systems out there that will work for adult monitoring, and there are plenty of them that are commercially available that function. And trap designs and lures continue to improve. If you're using adult trapping, you want to place them in shady areas, especially on the borders as well as on the interiors of the field. They often, again, as I mentioned, are coming in from the woods, so you want those border ones to see when they start getting active on the edges, but you're also interested in what infestation and how far they've penetrated into your field. So you want both the borders and the interiors. And as much as possible, you want to place these at fruit level on cooler and shadier sides of the plant where the flies are going to be more active. And here again is an example of what a spotted wing Drosophila looks like on a sticky card. And you can see there are some multiple kinds of flies and other things in this trap that you're going to have to sort through to find those spotted wing Drosophila. So identifying them is also an important component of adult monitoring. The traps are really good at telling us presence or absence, but they're not as good at population size. So we really recommend these, putting these in the field before your fruits start to color and using them as to let you know if spotted wing Drosophila is active and whether it's time for you to start a spray program. In that way, rather than trying to monitor how effective your sprays are with these traps, the population in the traps will go up and down. So for this year, our first adult flies were caught on May 28th in 2026. And I monitor spotted wing Drosophila at the Western Maryland Research and Education Center, which is up here in the corner. So it's probably a little bit, that's probably a little bit later than you might have seen activity, for example, on the Eastern Shore or other places of Maryland, because it is a little bit up in the mountains. The other thing that you can do is you can monitor for the spotted wing Drosophila larvae. And just to keep you in mind, there are a couple of other larvae you could find in soft-skinned fruits. Spotted wing Drosophila larvae are flies, so they do not have this little head capsule. You see this amber-colored piece that you would find on a raspberry fruit worm or on a sap beetle. And sap beetles also have a little bit of a tail, so to speak, on the back end, where spotted wing Drosophila are really just almost like a grain of rice. And then they have this darker area in their head region because that's actually their mouth part that they use to scrape the fruit. And you can see it through their thin skin. So this is what a spotted wing Drosophila larva looks like. For larval monitoring, looking for whether you have spotted wing Drosophila activity on your farm, it helps, especially on diversified farms, to check over ripe fruit and pre and post-harvest crops, not the crops that you're actively managing, because they tend to be there in higher numbers and easier to detect first, because they might be things that you've forgotten about. So if you have a little bit of floricanes in your primocane raspberries, for example, that would be a good spot to check. And then you also want to look for fruit in the interior and the lower canopy. Those tend to be hot spots. They prefer them because they're darker and cooler to lay their eggs. So that's a good place. And then, as I mentioned, this is what a spotted wing Drosophila looks like inside the fruit. It can be hard to find them in the fruit. Um, so I will mention in a second how to do larval flotations and pull those out better. Um, and then this is some other symptoms are soft, leaky fruits, as I showed at the beginning. So if you're touching the fruit and the tissue feels like it's breaking down, or you're seeing juice, or there's juice on the raspberry after you pull it off the receptacle, that's often a sign that there's spotted wing Drosophila. So in terms of larval monitoring, there's a really nice protocol for doing larval monitoring, of what we call a larval flotation. So you take the fruit, you gently crush them with a salt water solution, and you filter them with a coffee filter. And then here you can see the larvae are much easier to see when you do that. And you don't crush the fruit very hard, just barely open them so that you don't get a bunch of pieces of fruit in there. That makes it a lot easier. And there's some nice videos online on how to do that. So in terms of monitoring and risk assessment, there are other risk assessment tools that are incorporating weather and the likelihood of them being out that are in progress. We do not currently have thresholds recommendations. As I mentioned, if you have susceptible fruit and spotted wing Drosophila active, that's kind of a good judge. And your tolerance for having spotted wing Drosophila in your fruit is going to vary by your production system. There are situations that have zero tolerance, and there are situations that have a little bit more tolerance for having a few larvae in the fruit. So management is going to be based on spotted wing Drosophila susceptibility of the fruit. If it's turning color, it's susceptible. And then if they're spotted wing active. I also like to talk about behaviorally based management here, because this is another use of those attractants that we've been developing to lure them into those traps. You can have attract and kill systems or mass trapping systems, where you're basically trying to pull spotted wing Drosophila out of the system by catching lots and lots of them. There's also some repellents and feeding arrestants that are under development, and some of them are commercially available. Behaviorally based management relies on them not being attracted to your crop, or you being able to to kill enough of them that you're not going to have an issue. And so it seems like it is working quite well in blueberries, but it's not going to work as well in things like caneberries that they're really attracted to. And again, it can also break down if the populations are very high, or if there's not a lot of other resources in the environment for them to move away from. But if you there has been research into some of these alternative strategies as well. So moving on to chemical management, unfortunately for spotted wing Drosophila, we largely are still reliant on chemical management to control it. So, and we have, this is a ranking of the insecticide products that are registered and available for spotted wing Drosophila across all fruit crops. And this is what entomologists feel the efficacy were. So this is the average ranking entomologists gave those insecticides. And the insecticides are color coordinated based on their active ingredient mode of action. So there are some organic products like Entrust that rank pretty well, but I'm going to go ahead and move on from this, because this is where those efficacy ratings came from, to a table that I've put together that's more focused on blueberries and caneberries, which is where in Maryland we really see most of the problems. So there are a few products that are blueberry specific, like Lanate or Cormoran, where they're only registered in blueberries, that can provide excellent control. And then there's a lot of products that are registered for both blueberries and caneberries. And some of these are also in strawberries and cherries as well. But what you can see here is that we have multiple modes of action that provide good to excellent control. And it's really important that we rotate modes of action, because that helps delay the development of insecticide resistance. There's also some products that really have these short PHIs that you might be interested in if you're using a pick your own operation. For example, here, if it's in blueberries, it's 3 days, but it's 1 day in caneberries. And then there's also the bee toxicity ranking, or their potential hazard to bees. If it's H, it's high. If it's M, it's medium. And then we don't know what the bee toxicity ranking is for vertiprin. And as I mentioned, your most effective option for certified organic is Entrust, and these group 5 active, and it's in a group of 5 active ingredient. Some other things about insecticide efficacy. Caneberries are particularly hard to spray. They're particularly attractive to spotted wing Drosophila. They have very high pressure. And so there's really fewer insecticide products that work really well in caneberries compared to blueberries and cherries. And I have been doing insecticide testing of some products that are coming down the pipeline, and there are no new products on the horizon that I think seem promising. So this information has not changed. If you've heard me speak in the last few years, it's the same products that we have available. The other thing to think about, although not as much this year, is rain fastness. So if it's raining a lot, the rain will wash off the insecticide and you may need to reapply more frequently. There have been a few studies on their residual efficacy after rain or simulated rain that occurred in Michigan blueberries. They did not test all of the products that are available for spotted wing Drosophila, but they did find in blueberries at least that Mustang Max and X-Roll had a little bit longer residual efficacy after rain than products like Delegate and Malathion. So that's also something to think about if you're spraying in a situation where it's raining regularly. That may impact your efficacy and you may need to reapply. So the general best practices for insecticide applications for spotted wing Drosophila is that you're going to need at least weekly intervals for heavy pressure. You're going to need to reapply after rain. You want to rotate modes of action and you want to get good coverage. So especially as I mentioned, raspberries can be hard to spray. You need to get thorough coverage throughout the canopy into the center of the canopy where they like to hang out to really control them. So we did, my PhD student Maggie Lewis from 2016 to 2018 did some spray coverage field trials and laboratory trials that I'd like to spend just a second talking to you about to try to really see how can we get great coverage in caneberries. And we used an air blast sprayer, and then that air blast sprayer we didn't think was working all that well for our caneberries, so we actually added a row crop head to our air blast sprayer to really target that product more towards the canopy in these experiments. And we compared 50 gallons per acre and 100 gallons per acre as our carrier water volume, and also did assessments of commercial farms with the spray coverage that they were achieving with their standard sprays. In doing this, what we found overall across all of these different sites is that the spray coverage is really lowest in the inner canopy and the lower canopy. So that's where spotted wing Drosophila likes to hang out. So that's not really good news. We also wanted to see, does it really matter if we have poor spray coverage in terms of control? So in the laboratory here, you can see we have our paint sprayer actually that we're modifying the sprayer speed to get different amounts of spray coverage. This is a raspberry on a chopstick in front of a spray card so that we could evaluate spray coverage, and we turned that raspberry so we got both sides, and then we put that raspberry in with 5 spotted wing Drosophila and we looked at how well they survived. So this is the percent mortality, or the the percent of the flies that died. On the y-axis for the control, it was just water, or it was Mustang Max zeta-cypermethrin. And this is at a 50 gallons per acre carrier water volume. This is at 100 gallons per acre. The dark blue is the high spray coverage, where we were mimicking about 85% spray coverage, which was some of the better amounts that we saw in those field trials. And the low was about 22% spray coverage, and that's what that looked like on the card. So we did see, regardless of whether it was 50 gallons per acre or 100 gallons per acre carrier water volume, which those do have different concentrations in their droplets, right? That spray coverage, that higher spray coverage did kill more flies than lower spray coverage. So the spray coverage does matter to adult mortality, even when they're confined in there with those raspberries. But what we found was that the coverage didn't actually impact infestation for either droplet concentration. So low or high, just having that product on the fruit, they didn't lay their eggs in the fruit. So they it's possible that they were repelled from the fruit or something else was going on, but that was sufficient to prevent infestation. So that's good news on the spray coverage front. But overall, our messages from doing these field spray coverage experiments is that spray coverage is variable, and making adjustments had inconsistent impacts on coverage. So our recommendation is that you evaluate your spray coverage on your own farm to make sure that you're getting the coverage that you want. And again, with caneberries especially, really think about how you're getting the lower part of the canopy and the center of the canopy. And from the calibrations that we did, doing sprayer calibrations was the most, and making sure that it was well calibrated made the biggest difference compared to improving the carrier water volume in our experiments. So make sure that you're calibrating your sprayers. All right, moving on to some cultural control methods. My PhD student, Torsten Schoenberg, um, did a lot of work on cultural controls and also helped lead a cultural control review paper. So I'll very briefly talk about all of the different options that we evaluated. So we know that spotted wing Drosophila doesn't like very hot or very dry weather. So most of these cultural control options, the goal is to make the crop habitat less favorable for them. They may be pupating in the soil, so mulches and how you're irrigating could impact how they survive in the soil. Removing cold fruit for sanitation, pruning and trellising to try to open up the crop canopy to make it hotter. Shorter harvest intervals removes cold fruit also. These were all kind of evaluated. So, as I mentioned, they don't like how hot is too hot. They don't survive at a constant temperature above 87.6 degrees Fahrenheit in the laboratory. And then they stop egg laying at 95 degrees Fahrenheit in the laboratory. So, the hotter we can get it, the better in the canopy. And their lifespan and egg production also increase with relative humidity. So, they tend to do better, at least in the laboratory, at relative humidities greater than 70%. Unfortunately, in Maryland, it is often quite humid, um, and and we tend to be fairly conducive for them in terms of weather. They also can move around to avoid these hot, dry conditions. It's the larvae that really can't move around. So we tried pruning, we tried trellising, we tried mulching and irrigating to reduce spotted wing Drosophila infestation, and we could reduce infestation a little bit with a lot of these strategies. But our overall best practice recommendations after running the economics and looking at how much you can reduce spotted wing Drosophila infestation is that you should be doing all of these best horticultural practices to prioritize the yield and the plant health. And you will get an added benefit of reducing spotted wing Drosophila by not having those super thick canopies. But trying to do these cultural management strategies to manage spotted wing Drosophila is not very economically viable. We also did find in experiments that harvesting frequently and removing cull fruit can reduce infestation up to 60%. So a 1 to 2 day harvest compared to a 3 day harvest really reduced infestation in fruit. And what you do with that fruit also matters. So if you're harvesting and removing and destroying culls, you need to bag them, solarize them, or bury them to at least 9.8, 10 inches. And there's also been some people who are looking into composting and soldier flies to help remove those cull fruit, because otherwise the flies will just continue to develop wherever you put the cull fruit. But it does help to keep the sanitation does help reduce spotted wing Drosophila populations, and harvesting frequently does help reduce spotted wing Drosophila populations. And this is one of my points of advice. If it's gotten away from you and you really have a lot of infested fruit, and you can reset the situation by stripping off all of the fruit and then trying to implement your management strategies again. So this does work. On diversified farms, it can be hard to find all of the places where you have a lot of cull fruit on the farm that are producing these spotted wing Drosophila populations. So we'll wrap it up with some research and information about biological controls. There are quite a lot of biological controls that have been considered or are available for spotted wing Drosophila and this is a nice summary infographic of those I'll walk through. So there are commercially available nematodes and fungi. They have entomopathogenic fungi that would kill the flies. They have been examined and tested in various ways for spotted-wing Drosophila, but further work is needed to ensure their field efficacy and economic returns. So currently, we do not recommend nematodes or entomopathogenic fungi for managing spotted-wing Drosophila. We know there are a lot of predators and beneficial organisms out there eating spotted-winged Drosophila. These vary from arthropods like carabid ground beetles, row of beetles, earwigs, ants, to also there are people who are looking at hummingbirds that are eating spotted-winged Drosophila. So there are a number of predators that do eat them. Um, and they especially seem like they're eating and removing the pupae. But unfortunately, the best predators of spotted-winged Drosophila are the arthropods, and the arthropods are sensitive to the chemical insecticides. So it's hard to, in low input systems where you're not using chemical insecticides, biological control is helping. These predators are helping, but they usually do not provide sufficient control for fresh markets. Now, there are also another kind of biological control parasitoids. So these are organisms that develop within and kill their host. And so there are multiple native wasps that develop within spotted-winged Drosophila. But the resident wasps, the ones that were native to the United States, spotted-winged Drosophila actually has a really strong immune system. So here you can see these little black dots on the spotted-winged Drosophila. This is where the immune system suffocated the egg of the wasp. So spotted-winged Drosophila could actually suffocate the egg of the native wasps and still develop and survive. And these wasps are also not compatible with insecticides. So we really needed a better wasp, a wasp that was better evolved for dealing with spotted-winged Drosophila. So there has been a lot of research into identifying likely wasp species that could control spotted-winged Drosophila, and then also lots of commercial lots of studies in the lab to figure out which one's best. So, for example, here they went and explored in China, Japan, and South Korea, and they found two fagitid wasps and a braconid wasp that were parasitizing spotted-winged Drosophila in its native range. The wasps are color-coded, so you can see the one that was most common in most of the fruits was the Scanaspis camorum, which is a fagitid. So, and in some fruits, we got up to 60% parasitism from the different wasp species. So we got a petition approved to release Ganaspis camorum for spotted-winged Drosophila in 2021, and we have been releasing this wasp in Maryland since 2022. While this is happening, there were people in the Pacific Northwest who were also getting ready to do biological control and who were looking at spotted-winged Drosophila. And they found that Leptopolina japonica, the other species that we don't have a permit for, established itself in British Columbia. It's probably been there since 2016, but it was first found in 2019. It was also found in Washington in 2020. And actually, they also found Ganaspis camorum that had made its way over here by itself. So in the Pacific Northwest, both species had established them by themselves. But we have been working throughout the United States, rearing Ganaspis camorum for releases in all of these different areas, including our local rearing facility is in Delaware, in Newark, Delaware, and trying to establish them in regional insectaries. So our goal with importing these wasps is to have established self-sustaining wasp populations. And we really expect, as I mentioned, because we're going to be spraying commercial crops potentially, we want to establish them in the woods in all of these non-crop hosts like honeysuckles and mulberries that they're feeding on and doing well on. The wasps can go and find them in the woods. And hopefully that will help reduce the population in the early spring and in all of these places where we can't control them. So as I mentioned, we partnered with that USDA, and so far they've provided us over 12,000 wasps for Maryland that we've released. And here's just a little video. So we get these tubes of wasps. These are very tiny wasps. And then off they go, hopefully off to find spotted-winged Drosophila and establish. So we've been releasing them, as I mentioned, in non-crop areas in the forest. And we've been doing this at our Western Maryland Research and Education Center and on 2 diversified fruit farms. Um, we also have been trying to determine, have they established? So we don't just release them and send them on their way. We've been collecting fruit and non-crop fruit as well as crop fruit at these sites multiple times per year before and after the releases to evaluate how well they're establishing. So how we do this, because those wasps actually, they lay their eggs in the larvae of the spotted-winged Drosophila inside the fruit. And then they wait until the spotted-winged Drosophila pupates before they develop. So you have to rear them all the way through the pupal stage, and then you have to determine whether the pupa was a wasp or whether it was a fly. So we collect the fruit, then we pull the pupae out of the fruit. We wait for the pupae to emerge, and you can see if it's a fly, they actually have a balloon on the front of their head that they blow up to open up a little pouch on their pupa, and that flap comes off. And so you get this perfect little flap removed if a fly emerges from the pupa. Versus a wasp, they actually have, and this is because flies don't have chewing mouth parts, so they can't get out of their pupa any other way. The wasp chews its way out of the pupa. So you can see these jagged edges where the wasp chews its way out of the pupa. So since we've been releasing in 2022 and doing these fruit collections, the wasp that we've been releasing, Ganaspis camorum, we've recovered it at all of the sites, but we've only found 40 total wasps beyond the 12,000 that we released. While we were doing this, we found that other wasp that made its way over here by itself, Leptopolina japonica, is doing very well in Maryland. So it's the primary wasp that's parasitizing spotted-winged Drosophila at all of our sites, and we've reared 5,769 total Leptopolina japonica over the last 4 or 5 years. The other thing that we found is that the wasps are found from the beginning of the sampling till the end of the sampling. So we're finding them from June to October. That's great because that means they're active at the same time as spotted-winged Drosophila, and they're out there doing well while spotted-winged Drosophila is active. And we've also found them both in crop and in non-crop hosts. So they're out in the woods and they're also spilling over into the crops. So for example, this is our 2025 blackberry crop results. So this is the number of either spotted-winged Drosophila in red or wasps in black per gram of fruit that we collected. And this is the bar chart. And then the gray lines are the percent parasitism at our 3 different farms over the season from late June until mid-October. So you can see it depends on the farm, how many wasps and flies. And of course, the farms are managing spotted-winged Drosophila so with chemical insecticides, so they have less. At the Western Maryland site, I don't spray anything. So we have pretty high spotted-winged Drosophila populations. And our average parasitism we were finding in blackberries was around 11% at one of the farms, 9% at the other, and 25% at the Western Maryland site. Compared to raspberries, which they really like, you can see there were a lot more flies per gram fruit in the red, and also the wasp parasitism rates averaged around 25% at one of the farms, 17% at the other, and then 23% at Western Maryland. So we are seeing decent parasitism even in the crops. And so ultimately, we're really hoping that these wasps are going to help slow the early season population growth because they require these flies to survive. They're very good at finding them. So they can go out and find them well before you even know you have an issue. So finally, after all of those strategies, post-harvest cold storage and sorting can really help with the infestation as well. If you cool the fruit as soon as possible after harvest, the flies, whatever is in there, will stop developing. And you want to encourage your consumers to refrigerate. This also helps with the shelf life of the fruit. So that's the other thing that you can do. So in summary, in terms of our spotted-winged Drosophila best management practices, like all IPM programs, there's no one silver bullet. It's a combination of tactics, but timely harvest and horticultural best practices help. We're releasing wasps and hoping that will slow down the development of the population in the season. But we're largely still reliant on insecticides, especially in zero tolerance situations. And there are continue to be new management tactics that are nearing commercialization and more on the horizon. If you'd like more information, my website has a lot of our spotted wing Drosophila articles. You're also welcome to email me. And has been a team for many years that has been working at a national level, and they use swdmanagement.org to post their updates if you want some information on that. So I'd like to thank our funding sources, especially the APHIS PPQ, who has been funding those WASP releases. And I'm happy for questions and discussion.